Okay, welcome back, everybody. We are starting a new unit in geometry on the properties of a triangle, and the first topic of that unit is perpendicular bisector of a segment. So in this video, we're going to learn some new vocabulary. We're going to have a couple theorems that we're going to prove, and three examples which should help you get on your way to this topic, understanding this topic. Okay, let's start out with a vocabulary word here. Vocabulary word is equidistant. A point that is the same distance from two or more objects is equidistant from those objects. So if you think of the word equidistant as meaning equal distance, then you should be able to remember that. Okay, our first theorem that we're going to prove today is called the perpendicular bisector theorem. And it says this: if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So you see here line segment AB. And this line L is the perpendicular bisector of that segment. You can tell by the perpendicular symbols and also by the fact that AY and BY are congruent. So point X lies on that line L. So if a point lies on the perpendicular bisector of a segment, which it does, then the theorem says that that point is equidistant from the endpoints of the segment. So we want to prove that segment AX and segment BX are congruent. Okay, well, that's pretty easy to do. We're going to say that XY is congruent to itself by reflexive property. Then the two triangles are going to be congruent by side angle side. And once the triangles are congruent by side angle side, we can say that AX is congruent to BX by CP/CTC. Remember, corresponding parts of congruent triangles are congruent. So that proves that point X is equidistant from the endpoints of that segment, which is what we had to prove in this theorem. Okay, now the converse of the perpendicular bisector theorem is if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So what I'm going to do here is draw a line that's going to go through point X and be perpendicular to segment AB. So this line there, the red line, is through point X, so point X lies on that line, and that line is perpendicular to segment AB, and we'll say at the point Y. Okay. So our job is to prove that that line, which we'll call L, I guess we did that already, is the perpendicular bisector of segment AB. Right now we know the line L is perpendicular to segment AB because that's the way we drew it. But we want to make sure that it's the perpendicular bisector of segment AB. So we don't know that segment AB got bisected. So the way we'll prove that segment AB got bisected is we'll prove the two triangles congruent. Well, we know that AY is congruent to itself by reflexive property. And now we know the two triangles are congruent by HL because they both have a hypotenuse congruent and they have that common side, which is a leg. So the two triangles are congruent by HL. And that makes segment AY congruent to segment BY. Again, by CP/CTC, corresponding parts of congruent triangles are congruent. So that makes point X, which was equidistant from the endpoints of that segment AB. That was part of our given. That proves that it lies on the perpendicular bisector of segment AB because it lies on the perpendicular. That's the way I drew it. And it lies on the bisector. We just proved that segment AY is congruent to segment BY. So that's the proof of the theorem. Okay, let's look at some examples using our theorems. Now, some of these might seem easy to you, and they are, but I want you to make sure that you can give the reason behind it. Geometry is more than just about giving a correct answer. It's about the reason behind the answer. So if you look at this problem, we're trying to find out what is the length of segment YW. Okay, well, most people probably guess. But here's the thing. it's not about getting the answer again. It's about knowing the theorem that makes this problem easy. So if you look at point W, it lies on the perpendicular bisector of segment XY. We can tell that because that line, which I guess we'll call L here, is perpendicular to the segment XY, and it bisects it. You can tell by the markings there. So we have a theorem that fits this perfectly, and that is, if a point lies on the perpendicular bisector of a segment, which point W does, then it is equidistant from the endpoints of the segment. So that means that Wx must be equal to Wy. So this is 7.3. Again, probably could have guessed it, but can you quote the theorem which says it's really true? Okay, let's take another look at another example. Okay, so here we have to find the length of segment BC. So that's this piece right here. Now, there's people that can guess it and get it right, but again, the geometry students are going to be the ones that can quote a theorem that supports their work. Okay, so notice that point A is equidistant from the endpoints of segment BC. How do I know that? Because AB is 36, and so is AC. So point A is equidistant from the endpoints of segment BC. So the converse that we just proved says this: if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of that segment. So that means the line L is not only perpendicular, but it's a bisector. So that means that BD and CD are congruent. Well, once you know that BD and CD are congruent, you know that BD is 16, just like CD is. So if you want to find the length of segment BC, you're just going to have to add up those two pieces, which we know are congruent now, and get 32. Okay, so we use the converse of the perpendicular bisector theorem to reason our way to get the length of segment BC. Okay, so our last example today is going to be one that's you're going to have to kind of really think about to understand. You see here in this screen here a line segment AB, and you know the endpoints of that line segment. They're given. Our job is to write the equation in point-slope form of the perpendicular bisector of this segment. So roughly, if I can get this right here, that perpendicular bisector will look something like that. So that line, that red line, is going to be the perpendicular bisector of segment AB, and we want to write its equation in point-slope form. Well, what do we need to know to write an equation in point-slope form? We need a point and a slope, just like the name says. So as a reminder, here's the point-slope form. Y minus y sub 1 equals m times x minus x sub 1. So we're going to need a point on that red line and its slope. Well, how do we get a point? Well, the only way to get a point right now is to find that point right there, which is the midpoint of segment AB. Now, you don't need the graph paper to tell you that. Matter of fact, we could have done this without graph paper. Let's call that midpoint M. How do we get the coordinates without even looking at graph paper? You use the midpoint formula. So you take those two x coordinates and add them up. Negative 1 plus 3 is 2, divided by 2 is 1. So 1 is the x coordinate of that midpoint of that black segment. Repeat that process for the y coordinate. 6 and 4 add up to 10, divided by 2 is 5. So 1 comma 5 is the midpoint of that line segment, and that red line passes through that point because that red line is the perpendicular bisector that we're supposed to write the equation for. Okay, now how do you get the slope? We got the point on the perpendicular bisector. That's all we need is 1 point. We need the slope, though. Well, you can't find the slope directly because you don't know any other points on that perpendicular bisector. But we can go at kind of in a roundabout way. Let's get the slope of AB. Let's get the slope of segment AB, which we can do because we know 2 points, and then take its opposite reciprocal, because we remember that lines that are perpendicular have opposite reciprocal slopes. So let's find the slope of line segment AB right now using the slope formula. So subtract the y, so 4 minus 6. Those go on top. Then subtract the x's, 3 minus negative 1. All right, so we got a negative 2 on top and 4 on bottom, so it's negative 1/2. Remember, that's the slope of the black segment. We want the opposite reciprocal for our perpendicular bisector, the red line. So that slope right there for that line is going to have to be positive too, because that's the opposite reciprocal of negative 1/2. Okay, now we got a point right here, and we have a slope. That's enough to write the equation of that line. Let's plug them into our point slope form. So we have y minus 5 equals your slope, which we just said was 2, times x minus 1. Okay? And since we said that just had to be in point slope form, we could just leave it the way it is right there. We don't need to solve it for y. That's going to be the equation in point slope form of the perpendicular bisector of that black line segment. Okay, let's do a quick review of what we learned in this video. We learned about the perpendicular bisector theorem. That is, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. We also learned the converse of that theorem. That is, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of that segment. Then we did some examples for that. So let's take that information and put it to practice on the assignment, which is already posted. And best of luck on that.